43 seconds. That's all the Holland belt loader needed to fill a 110-ton truck with earth, a feat that promised to transform mass excavation forever. So why were only a handful ever built? Mass excavation always faced a coordination bottleneck. Shovels struggled to keep heavy haul trucks moving without idle delays. In the early 1970s, Montana-born civil engineer and contractor Francis Mike Holland set out to solve this. Having operated a Fresno scraper on his family ranch near Billings, and later Euclid BV traveling belt loaders, Holland knew the limitations of existing machinery. He grew frustrated by the Euclid's frequent clogging and restricted material flow. Around August 1972, he introduced a machine that combined scraper cutting with continuous conveyor transfer. The same idea, just bigger and more modern. At the front of the machine, a heavy vertical cutting edge sliced directly into the bank. As the tractors moved forward at about 3 miles per hour, this blade sheared the soft earth, letting gravity drop it directly onto an integrated 72-inch conveyor belt. Unlike the earlier Euclid BV loaders, which struggled with 54-inch belts, this wider design and its reduced slope kept material moving upward and rearward without clogging or rollback. The continuous conveyor dumped the earth straight into waiting bottom dump trucks, bypassing the slow swing, dump, and return cycle of a conventional shovel. Traction and movement came from Caterpillar tractors, while a separate 410 horsepower power unit provided a more efficient drive for the conveyor, though some model variations remained unresolved. To handle these immense forces, the loader had no traditional undercarriage. Instead, the frame mounted directly to the tractors, transferring the cutting and conveyor forces through the mounting structure and onto the bulldozer tracks. This layout used the machine's own load path to maximize traction and stability, although exact operating weights, mass breakdowns, and detailed hydraulic or transmission specifications remain unconfirmed. In 1972, this concept met its first major commercial test at the Perris Dam project in Southern California. Over a sustained construction run spanning into 1973, contractors deployed a fleet of 4 Holland loaders, each paired with 2 massive Caterpillar D9 or D10 crawler tractors. This was no brief demonstration. It was a grueling, high-volume production operation feeding a steady stream of Euclid bottom dump haul trucks. The physical scale of the system delivered immediate, measurable results. In loose loam and sand, the loader filled a 110-ton Euclid bottom dump in just 43 seconds. When the material turned to heavy ripped earth, the loading time stretched to about 90 seconds. Operating over 2 full shifts, the 4-loader setup moved between 75,000 and 120,000 cubic yards of material daily. This rate of excavation captured public attention, prompting a 1975 headline declaring that a new device gobbles earth, though this was more of a spectacle than engineering proof. Manufacturer literature would later claim that larger models could load even bigger 180-ton trucks in under a minute, but the real proof of the design's capability lay in those daily production logs at Perris Dam. In the early 1980s, the loader moved to highway construction on the Interstate 8 project near Casa Grande, Arizona. Here, contractors paired the machine with 2 Caterpillar D9G bulldozers to feed 50-yard belly dump trucks. During a project demonstration, the setup filled each truck in approximately 50 seconds. This rapid cycle time directly reduced truck waiting times, demonstrating how tightly excavation and haulage could be coordinated on highway earthworks. By 1984, the machine's utility extended to municipal infrastructure at the Union Hills Water Treatment Plant excavation in Phoenix. While historical records from this Phoenix project omit specific truck models and exact production rates, the deployment confirmed the loader's capability on complex municipal utility sites, proving its design could adapt to projects beyond massive earthen dams. Despite its speed, the Holland belt loader remained rare, with only a handful of units built before the company closed in 2012. The machine required a narrow operating envelope, massive excavation volumes, vast working spaces, and a dedicated fleet of large bottom dump trucks. Geometrically, the revised belt layout mitigated but could not cure material sensitivity. In the field, operators faced belt wear, slippage, rollback, and clogging at transfer points, Lacking the maneuverability of hydraulic excavators, and with no independent cost per ton data comparing it to traditional scrapers or shovels, this specialized loader stayed a niche solution. The Holland loader represents what the Historical Construction Equipment Association frames as a next-generation evolution within the traveling belt loader lineage. Its integrated systems logic directly informed later high-capacity mobile conveyor concepts used in surface mining and large civil works. However, this conceptual influence never translated into universal commercial adoption, and traditional shovels, scrapers, and excavators remain the industry standards. Today, archival records are scarce, and no confirmed patents are directly attributed to Holland in the historical material. With only a handful of these machines ever built, the surviving physical examples remain exceptionally rare remnants of an ambitious attempt to rewrite the rules of bulk excavation and haulage coordination. Today's mega projects still chase the extreme efficiency Holland envisioned. His giant loader proves that even niche, forgotten machines permanently reshape the landscape of modern engineering. Subscribe for more.